Step 5. Identify the test statistic that is relevant to the test and then determine its sampling distribution, such as normal, t, or the chi-square. Since we're dealing with a sample proportion, then we're going to be dealing with the normal distribution. Now, what was given in the problem is that the sample size n is equal to 926. The value of p, the population proportion, is 0.5. The value of q is equal to 0.5. And the point estimate is the value of x, which is 482, divided by 926, which gives us 0.520518359. So now we're going to plug in our values into the formula. So let's go ahead and do that. Well, the point estimate is equal to 482 divided by 926, which gives us this value, 0.520518359. And then we're going to subtract the population proportion p, which is 0.5. And then we're going to divide that by the square root of p, which is 0.5, p times q, which is 0.5. And then we're dividing it by the sample size of 926. Let's go ahead and put this in our calculator. Okay, so if we take a look at the numerator as a decimal, we have 0.520518359 and then subtract 0.5. Okay, that's going to give us what's in the numerator. Another way of doing this is just writing this fraction in parentheses. So if we put our left parenthesis, 482, and then divide that by 926, and then subtract 0.5, then we get the same number here. Now, once we get this number in the numerator, we can divide that by the square root of 0.5 times 0.5, and then we're dividing that by parentheses, the sample size 926, and then that gives us the following, 1.248757482. Now, with the test statistic, we need to then round that to 2 decimal places. So we end up getting 1.25 for the test statistic. So again, let's identify this as the test statistic. So this is our test statistic, which is our z-stat value.